So tonight, we have Qualcomm in the house. I'm going to talk about improving power and performance of your Android apps. And also, it'll be a nice kind of dive into what does Pokemon Go look like on the performance side, and what is it doing to your poor little phone. How many people have had it like on an iPhone just like basically kill the phone? Maybe the first week it was doing that to me. And then we have some other VR apps. I think I'm going to take a look at Kevin's. I'm going to have a look at. So we have some awesome stuff to cover tonight. And if you guys are tweeters, tweet MobileMonday #Qualcomm for tonight. How many people first time tonight? MobileMonday. Wow. Let's see. This is awesome. So this is a little bit about me. I'm Mario Tapia, and how many people found Meetup? How many people found us on Meetup? Okay, who people are from Eventbrite? The trolls. You guys troll events. I know. You guys are trolls. What's going on in LA? I'm in LA. What's going on? It's awesome. No. And then so who got like my newsletter? Did some people find my newsletter or something like that? Yeah. Okay. Cool. So I've been doing this 1999, getting mobile developer guys together, ecosystems, Seattle, Silicon Valley. So I live in San Francisco, downtown. I live a block from the Giants Stadium, and I don't like the Giants, or the Dodgers. Sorry, guys. But I've been, as a fun hobby, I've been trying to run these different developer groups here in LA. And I think 10 years ago is when I started the group down here. It's gone through different hands through the past couple of years. But lots of fun stuff going on, right? LA is, it's got tech, it's got drones, it's got VR, it's kind of cool stuff. I've also been hanging out in New York, and it's really interesting that the vibes between the three different cities, like you guys, is pretty much the same. It's really cool because people are experimenting, they're trying new ideas, and it's not that expensive to get your idea up and running and get some investment. So that's what my interest is. I really want to see the startups. You're talking to the guy who met Travis when he demoed Uber at MobileMonday with one black car, or Dennis Crowley with Foursquare when he was launching this thing before South by. So I've seen all these really cool startups from you guys just in the middle of the audience, and you never know what's going to happen. You guys might get very lucky. So that's enough about me. Tonight we'll do a quick overview for a lot of newcomers tonight, and then Kevin Qualcomm will do some, and then I think we're probably going to skip the demos tonight because we had some applicants, but we couldn't find anything really wrong with your apps. So, and there's more networking. So right now I'm kind of just organizing Silicon Valley, Silicon Beach, and Silicon Alley. Overall, you guys I have an email list of over 30,000 of you. So it's been fun getting to this stage. But overall, over the last 10 years, there's about 140 cities around the world, so from Tokyo to Tel Aviv. There's a Mobile Monday happening a certain Monday of every month. From the audience, this is kind of the general, because if some of you on Eventbrite, I was able to ask you questions, but how many people are developers here, right? People who write code. Wow, okay, cool. Business development, sales, okay, drink more caffeine. You might fall asleep on this. Product and marketing, because this also might be fun for you, because you get to understand what your developers are facing. Venture? I didn't find any venture to this one. Design, okay, unicorns, designers. Any people with UI, UX? Yeah, there's a few. Okay, cool. So tonight is our lab night. We do a monthly topic as well, or quarterly in LA sometimes, but we basically have like a general panel discussion on a certain industry topic. Hopefully we'll actually probably do something in VR later this year at the CAA. And I also do some dinners. It's just like it's free to attend, free pizza and stuff like that, thanks to our sponsors. And also, you can find us, where to find us, mobilemonday.us. Actually, the meetup is actually Silicon Beach, not Silicon Valley. But we also have Silicon Beach for our Facebook. And this is being recorded. So I have I think over 70 meetups now on YouTube, all types of discussions. So If you're interested in beacons, we have some awesome conversations on beacons, mobile advertising. If you're into anything in the app ecosystem, how many people here are interested in IoT? So IoT says, yeah. So that's like another emerging part of our industry. So we have a ton of stuff on connected home and health. So there's a library, ton of stuff. It's free. If you guys want to take a look at it, go right ahead. But also tonight, I'd like to thank our event sponsors. Thank you for the beer and the pizza. Please give them a round of applause. Kevin, Qualcomm, and we've been doing stuff for a couple of years now. This is great. And also WeWork. How many people first time at a WeWork? So yeah, it's kind of a cool space, huh? I like the hipster design. Very cool. I've been to WeWorks like New York and Silicon Valley and all these other different cities, which is pretty awesome. So it's nice to have a place to crash or do some work. But thanks to the folks at WeWork for hosting us as well. So I think that's it. So I'll hand it over to Kevin. Okay, take it away.
Hello. My name is Kevin Hawkins. I'm from Qualcomm. I am a principal engineer there. I have a team. We develop developer tools, and that's what I'm here to talk to you about. A lot of our developer tools have to do with performance on our chipsets. Who here is familiar with the Snapdragon chip? SoC. Fair amount. Who's familiar with Qualcomm? So Qualcomm is known for its wireless. That is our bread and butter. But we do have what we call an apps processor called the Snapdragon chip, Snapdragon SoC. And this chip powers a lot of phones worldwide, billions worldwide. I have a Galaxy S7 today that I'll be using. It's powered by our Snapdragon 820 that came out, I guess, earlier this year. We have a lot of other devices coming out throughout the rest of this year. Got a couple of use cases I want to go through. I'm not going to necessarily tear apart apps and say they're doing all these things wrong, but try to highlight things that the tools can show you for use cases that you want to try to avoid, things that you definitely want to try to avoid. There's some general patterns that we've learned over time, things that you don't want to do that are going to kill your power, going to kill your device temperature is going to rise, or just generally might hurt your performance. So feel free to interrupt me with questions. I don't mind. I'm pretty casual about that. So we'll get started. Quick overview of all the tools that we offer developers. We're going to be talking specifically about the Snapdragon Profiler and the App Tune-Up Kit, both profiling tools. But we have SDKs that you can use, libraries that you can use to take advantage of the chip. One that I'll mention a few times today is called Symphony SDK. And is anybody familiar with heterogeneous computing? That phrase, what it means? What does it mean?
It means being able to, I'm sorry.
Putting you on the spot.
Yeah.
Heterogeneous compute, when we say that, we're talking about, rather than just running code on the CPU, you're also leveraging the GPU and the DSP. And on a chip like the Snapdragon SoC, there's a lot of different chips. The chip itself is maybe that big at most, and it actually has 10, 20 different chips on it, doing all kinds of different functions. Three primary ones that we focus on is obviously the CPU, but also the GPU for graphics, but you can offload processing there, and the DSP, which traditionally in a cell phone is used for audio processing of your voice. But we're finding ways to leverage that chip to do different types of signal processing. We have math libraries if you're doing any kind of intensive math computations. The Adreno SDK is our graphics SDK. If anybody familiar with Vulkan, the Vulkan API? This guy. So we do support the Vulkan API for anybody doing any graphics development. The FastCD SDK if you're doing any computer vision, especially IoT, computer vision is kind of becoming a big thing in that space. The FastCD SDK is intended to help you optimize your application on Snapdragon. The Hexagon SDK is for programming the DSP. And we just announced and released the VR SDK. which is intended to be a very low-level library for anybody doing VR development to take advantage of Snapdragon and get the best optimization for VR apps. We also have a debugger plugins for Eclipse and Visual Studio. We have an LLVM compiler for C++ code. And we do have various dev kits, if you're not familiar with that. Our mobile dev platform is basically a big cell phone platform. We have embedded dev kits and IoT dev kits as well. Very, very small boards, kind of Arduino size that you can get. So, like I said, we'll be talking about the profiler and AppTuner kit. The AppTuner kit is something you may be interested in if you just want a general idea of how your app is performing or whatever code you have running on the device, how that's performing. The general idea is that you can kind of profile your app in 60 seconds or less. Just get a really rough idea of what's going on. So kind of going through stages, profile, analyze, and then we actually provide recommendations based on the information that we gather. I'll run this real quick just so you can see. Bear with me, multitasking. And I don't usually use Macs, so bear with me there too. I'm going to use, anybody know the tool Visor? Yeah, love it. All right, so let me make that bigger. All right, so quality is not the greatest, but you can at least see what's on the screen. I'll talk about Pokemon Go.
All right.
I'll show you why it gets so hot. Let's see, so we're on the AppTuner kit. So when it starts up, basically you can select your application. It looks at every application you have installed on the device. I am just going to profile the weather app just to keep it simple. I just want to give you a general idea of what this does. So I've set my profile duration to 30 seconds. There, a combo at the top. And I'll just hit the weather app. So it'll bring up weather app. It's a warm day. And right now, if I can use my app, maybe I want to test a specific function. In this case, I'll do a refresh, so I'll probably pull some data over the network. And sooner or later, TuneUp will take back over. And we'll see what's going on. Okay. So TuneUp looked at power. Now, why was power so bad? Probably because I did a refresh. And we'll talk about that with Pokemon Go. We see a CPU rating worse than average. It's also probably because of the refresh, if I had to guess, mainly because processing a lot of data from data source. GPU is something that you have to enable using Snapdragon Profiler. Reason being, because we actually tap directly into the driver. And with Android permissions, you can't necessarily do that from an APK. So we have a way where you can use Profiler, say, turn on GPU for AppTuner Kit, and then you're set, and you'll get GPU data. But in this case, you won't see anything. Thermal, good. We didn't see a lot of variation, is really what that means. And that refresh was half a meg plus. So that's kind of a lot for just updating some basic weather data. You can also scroll down and see a little more detail on what's the load on the various CPUs. You can see your peak power, your average power. The peak power would obviously be during the refresh, but generally speaking, the average power is not too bad. One caveat, I am plugged in on USB, so power's not totally reliable. Usually you would use this without being plugged in and get much more accurate measurements. In this case, what we're looking to do is just understand in relative terms where are we at. Okay, so any questions about AppTuner Kit? Just really kind of want to highlight it. It's something that's on the Play Store. You can download it now, try it out, whatever.
You didn't do it for iOS?
No, it's only on Android. Apple does not use our apps processor.
Is it possible to increase the time for 60 seconds?
Yeah. If I go back to that profile duration selection, you can actually do it manually. So if you like the way manual works is you can go to your app, do whatever, and then actually go back to App Tuno Kit, and you'll actually see things update in real time. Okay. So I'll talk about the profile a little bit because that's the tool I'm going to show Pokemon Go with and a few other things. Snapdragon Profiler, has everybody heard the term an SoC, system on a chip? The Snapdragon chip is that. It's composed of all these components. All the processing happens on this one chip across the entire device. So Snapdragon Profiler is intended to show you what's happening across all those components. We don't necessarily have every single one of these blocks filled right now. We released it actually about a year ago today, interestingly enough. We don't support all these components, but we do have CPU, GPU, DSP, which are the primary things that we're focusing on right now. So with CPU, you get your utilization, your frequency, your CPU load, which is a calculated data point. For the GPU, we support GPU utilization, texture fetches, shader performance across OpenGLES, OpenCL, and Vulkan APIs. The Hexagon DSP, you can see how much the DSP is being used. Look at bandwidth and look at all kinds of counters that exist on the DSP. We've specifically been building Snapdragon Profiler to better support virtual reality. Virtual reality is bringing about a whole new set of use cases. New ways that these graphics APIs are being used. It's forcing design changes to the chipsets themselves. And so we're trying to leverage that to help everybody design better VR apps. It works with any Snapdragon powered device. So if you have an IoT device that's Snapdragon chip, it'll work with that as well. And I'll get into the different things it does. Answer common questions. It's plug and play. You don't have to root your device. If you do root your device, you do get a few extra things that we can't get otherwise. But this S7 I have is straight out of the box. It does work on Mac, Windows, and Linux host PCs. Right now, Android targets. We are adding support for Brillo, embedded Linux, and a couple others I can't mention. All the GPU features require Snapdragon 805 Plus chipset, or later chipset. I think the 805 was a Nexus 6, which the one that was released 2 or 3 years ago. And then I mentioned the graphics APIs. So to give you a little bit of background though, because a lot of what Snapdragon Profiler does is graphics centric, and the reason being is that internally at Qualcomm, my team comes from the graphics team. And what we've done is taken the profiling capabilities that we had with our Adreno Profiler tool and brought them into the full chipset. And that's just an ongoing development that we're doing. This is what it looks like. This is the real-time view. So here at the top, we got CPU frequencies that are stacked together. CPU utilization, these are across 4 different cores. We got system memory utilization. And this whole top section is actually what we call the system metrics. And here in the bottom section is a set of metrics, FPS, frames per second, and CPU utilization for a specific process. So you can see what's happening across the entire system, and you can narrow it down to a specific process as well. In the top left is your list of processes that are available, and then below that is your list of metrics. When we first started designing this, things were relatively simple. We didn't have a lot of data, but I think now we're getting in like the 150 metric range, and we're about to explode to probably 300 here in the next few months. So some of this will probably be redesigned a bit to make it more usable. Had a question at the last meetup we did. Will it work on background apps or widgets? Yes, it will. We found out during the meetup that it would, because we had never tested that. The second mode we have is called the trace mode. Familiar with the Android systrace tool? Okay, 1, 2. So Android systrace, common tool used for Android profiling. What we've done is taken what Google provides out of the kernel traces and built around that, so that everything goes on one timeline. So the Android systrace data, what you see here is pretty much the entire top, like 4/5 of the screen. That you can get with Google's tools as well. But what we're doing is that bottom section is data coming out of our graphics driver. That's stuff that's proprietary, you can't get anywhere else. And what we're doing is correlating that across the CPU, the GPU, and the DSP. So as we add more functionality to this, it's becoming more and more powerful with being able to see from a heterogeneous computing perspective what's happening across the SoC. The last one we have is coming from our graphics background, what we call snapshots. It's basically what's a frame capture. I think I'm gonna guess we only have one graphics programmer in here. Is that right? Okay. Not to single you out. So doing a frame capture, you can see the scene that is captured. You can view all the different objects. You can look at all the textures. You can look at all the attributes of the textures. You can look at all the draw calls and see what data went into those draw calls. You can actually take your shaders and programs and modify them, upload them back to the device, and see the impacts from a visual perspective. And then in the top left we have what we call pixel history. So you double click and you can see what are all the draw calls, what are the stages that went into rendering that single color. So, and a lot more. For anybody interested in Vulkan, we did add Vulkan support in a recent release, and this is just a screenshot to show what that kind of looks like. Basically being able to see it on the timeline, again, correlated, and being able to see all the Vulkan API calls that were captured. I'll skip that. One other thing we added to the trace is actually being able to see GPU metrics. So you can see what's the clock frequency of the GPU at every single draw call of execution. Pretty powerful stuff if you're trying to isolate to what's causing a frame drop. Okay, kind of shift gears real quick. I want to show you a real use case that I experienced. This is actually probably almost a year ago now. While we were developing, I had a device sitting on my desk, and it was, I was testing stuff, and we have various internal demos. So this demo maxes out the CPU. You can't quite see it here because the numbers are too small, but these core frequencies are pretty close to maxed out. And I had left it running. I got interrupted, helped somebody out, come back to my desk, and started watching the graphs again, and I see this happen. So, does anybody know what thermal throttling is? Like, why does that happen? Right. So we'll also hear a phrase called frequency collapse. This is what it looks like. When your phone gets too hot and everything starts to stutter, this is why. So in this case, this demo had been running and the temperature was 65 degrees Celsius, according to the profiler. And basically what happens is the scheduler and the software that Qualcomm writes to protect its SoC, because we don't want it to melt on you, drops all the frequencies down. So I believe, if I remember right, these frequencies per core were dropping to 300 megahertz. I was running a high-end graphics demo. It basically just started chugging. That frequency collapse lasted an entire minute. If you think about it, if you had a game or you had some other processing-intensive application, you wouldn't want this to happen to your user. It'd become very, very frustrating. But this is what happened, and the system waited until it had a steady state at 55 degrees Celsius, which is still pretty hot. But
So this happened on the GPS apps in the car. And so just putting it next to a ventilator, that just drops the temperature and then the CPU will continue with that noise.
yeah,
So it's really a physical.
it's a physical thing. In fact, I mean, I've done little tests where I take it and just like squeeze the thing and get this to happen. So the system sees that we're at 55 degrees Celsius, and then we resume execution. And you can see the temperature started rising back up again and started leveling. There is some intelligence to the scheduler and to the system software to try to prevent this from happening as much as possible. I think in this case, I think the phone was sitting right next to my fan that was blowing all the hot air.
Well, if the frequency is dying like that, what's actually happening in the application? Like, is it still...
Well, it depends on the type of application. Like in this case, this was a high-end graphics demo. It was basically equivalent of a high-end game. So frame rate just dropped.
Right.
Yeah. So, which in turn affects your user experience, right?
So frame rate drops or skips frame?
Same thing, yeah. So did I have it up here? No. So that particular demo typically runs at 60 frames per second. And it was stuttering, so I guess anywhere from 5 to 10 frames per second is what it dropped to. It's also, that particular demo is also a very CPU intensive application. So if it doesn't have the full processing power of the CPU, you know, the data is not going to pass through as quickly.
Instead of a home now, like it's either on or off.
No, there is stages, and that's what actually happened. Is it dropped to, because things got so bad, 65's reaching a certain threshold that you don't want to reach, so it just totally collapsed down to the first stage in this case. And that's actually why it's kind of a really good example. And the reason I bring this up is I want people to be aware that this is a real thing. You know, apps that don't manage themselves very well, they can trigger this, and we do see this. But part of my team's job is to analyze apps and help developers out, and we will see this kind of thing. Any other questions?
How does this relate to mobile web versus apps?
Good question. Mobile web has its own set of challenges, I guess. I think that's actually something I've been thinking about, because some of the other stuff I wanted to talk about, I've been thinking about mobile web from the standpoint of what can you control and what you can't, because you're running in a browser. So I think there's, in this case, I'd say anything that might hang the browser, obviously. Anything that's client-side processing is going to be what affects this. But then there's trade-offs. I guess, let me hit on a little bit of that. So I want to talk about some of these things in a little more detail. Definitely stop me if you have questions on anything. It can be more of a discussion too, because these are a lot of patterns that my team sees, whether it's internally developed apps or apps that we're helping out with others. And web has actually been something that we've been put a little more focus on. So if anything pops in your head, please speak up. So yeah, I want to cover power and thermal impacts. That's, to be straight up honest with you, Qualcomm cares about that a lot, because if devices that are using Qualcomm chipsets are overheating or having a lot of power drain, then that affects Qualcomm, because it's the chip that gets blamed, even though it's the software that's actually causing it. So I want to talk about ways to help prevent high power draw and high temperature impacts. And talk a little bit about VR, AR latency, some things that are going on there. And then a little comment about background services, because that's something that we've come across very recently in interesting little story. So, when we have a high power draw or temperature impact, I already kind of hit on this, but there's really one thing that causes this, and that's high CPU core frequencies. When you're pegging the CPU, and there's things that you can do about this when you have a system on a chip. One thing is try to perform the data processing in chunks. What do I mean by that? Rather than just doing all your processing all at once, try to space that out a little bit. That way the core frequencies don't rise up as quickly. Going back to this chart, like I said, this particular app is maxing out the CPU 100% of the time. If, granted the type of app that it was, that's what it was intended to do, but if it could reduce that even 80%, this wouldn't even come close. The temperature would never really happen. And I'll show that to you here in a minute. Another way to reduce, if you can do any server-side or off-device processing, and that's actually something I've been thinking about with the website. I know pretty much everything's going client-side with web these days. That's not necessarily going to help you on a mobile device when it comes to reducing power and reducing thermal. I put an asterisk there because there's a caveat, of course, with everything. There's always trade-offs. And the caveat is with network data, which I'll hit on here in a few minutes. The third thing, and the thing that we recommend because you can get the best possible processing, is to offload, do asynchronous processing on the GPU and the DSP. And the Symphony SDK that we have makes this much easier to do. Couple of examples though. GPU, if you're doing any vector matrix data processing, if you're doing any machine learning, the GPU is built for that kind of data. It also draws less power than the CPU. That's where you want to do that kind of stuff. The DSP, it's built for processing data series. Anything you're doing along those lines, you want to use that. It draws way less power than the CPU. How do you go about doing that? That's another topic. That's a whole 10 other meetups. But we do offer the Symphony SDK to help you out with that. And I just want to kind of throw that out there because everybody wants to know, well, yeah, I don't want to max out the CPU. What are my options? These are three of the most common options. Ways to reduce it. Again, like I said, it's not about not using the CPU. It's just trying to use it a little smarter. Not, if you got something that's going to take 2 seconds to process all the data, don't do it all at once. Try to background process it. Try to partition it out. Try to spread it out over a couple seconds if you can. Maybe find ways to compress or reduce the data. Look at different ways of doing that. So, before I go to the next one, let's do something besides slides. Just to kind of show you some of the stuff in action. So I've loaded up Profiler. I'll try to get it big here. All right, so I'm going to connect to the device. All right, so once we're connected, you'll see logline fills up. I'm going to go and close that because it's distracting. And I was just talking about CPU. So select the real-time tab. So this is our viewing all the real-time data. And drop the frequencies in. So right now the device is quiet. You can see there on the visor screen, and nothing's going on. It's the home screen. You'll see these little spikes of the CPU. That's your background services doing stuff, whether they're pinging home or refreshing the home screen or whatever. These big spikes are generally not good, but they're going to happen. And throw thermal in there. Since I'm on USB, I'm not even going to bother with power, just because doesn't make any sense, or it makes sense, but then I have to explain it, and that takes more time. So you can see, the device just sitting here, you can see even when these short little spikes happen, that we're still, 26, getting very small fluctuation, but 1 to 2 degrees Celsius, roughly, every time those core frequencies spike up. So I have a demo app that we made. I had somebody on my team make a while back to kind of show some of the stuff. So it's a terrible looking programmer art kind of app, and it doesn't run very well. You can maybe see in the top left it's running 5, 6, 7 frames per second, jumping around a lot. You'll also notice ever since I started it that the temperature has risen dramatically. And I'll zoom out just so you can see. So we started at 26, and now we're in the 54 range. So this is an optimized version. I have a little button that I can optimize, but you can also see the core frequencies are pretty much getting maxed out. I think per core, 2 of the cores are 2.4 gigahertz, the other 2 are 1.8 or something like that. But together they are adding up to what you're seeing on the screen here. You can see the temperature did drop, the frequencies collapsed. There was a little bit of a frequency collapse there in action. But I'll go ahead and hit the optimize button. And you can see the core frequencies have dropped. We're getting 60 frames per second, and the temperature is dropping a bit as well. Now it's not going to go all the way back to 26 or whatever it was at, or it might over time, but the heat dissipation takes a little bit of time to get back. Plus, we're running a graphics intensive app as far as the system is concerned, so it'll take time. But hopefully this kind of shows you this is real. The CPU is going to raise your temperature. There's other things that will too. So I just threw in the GPU utilization. It is around 30%. I just did the other optimized things. I don't think we'll see any difference though. Yeah, it kind of leveled out the GPU. I'm sorry if that's really dark. So the other optimizations are to optimize the graphics pipeline a little bit. And you can kind of see that when, before I hit the optimize button for the GPU, it was thrashing a lot. That's just because we weren't optimizing the data that we were sending to the GPU. And then once I optimized it, it's kind of leveled out. So from a performance standpoint, things are much more clean, things are much more, the data pipeline is much more optimized. The net result is that it consumes less power, but like I said, the power wouldn't make sense since I'm plugged into USB right now. So, any questions about this? Just want to provide a real example. Okay. Since I have it up, I'll go ahead and show the trace. What I just did is created a new trace capture, and here in the metrics are, I have a bunch of DSP metrics, and you can see, there's like 100 of these things. You kind of need to know more about the DSP chip to know exactly what they all are, but that documentation is on the web. This section here, though, is basically the Android systrace data. So I selected the CPU scheduling, and then I'll select the demo, and oops, I messed something up, so we'll come back to that later. All right, so The second thing I want to talk about is the network. This has come up a few times already. When I mentioned the web stuff, one thing people may or may not realize is that the wireless chip consumes a lot of power. Just ramping it up to send data is going to spike up your power usage. It's why apps that, or let's say streaming video will kill your battery. That's pretty obvious. I think everybody knows just from using their phones that the more you use it, the more you use the internet, the less battery power you have. The number one reason is because of that wireless chip. Every time you send something, you're ramping up the wireless chip to execute, and that ramp up period is what sucks away all your power. It doesn't seem like a lot because we use our phones every day, we use it throughout the course of the day. They tend to last a full day, even with heavy usage these days. But they could last 7 to 10 days if we were a little bit smarter with how we use the wireless chip. So the way to reduce that is, what I just say is, don't spam your server. You don't need to send updates every second. Pokemon Go. It's way better to send 100 kilobytes. That way you're not ramping up the power or the wireless chip, ramping back down to send 10, ramping back up, ramping back down. It's way better to batch that stuff together and just send one big data buffer than to send 10 kilobytes 10 times. And generally speaking, try to minimize the data transfer. Data is not free. We know that from our plans, but even from a power consumption, from a thermal standpoint, from a silicon standpoint, it's not free. So I'm going to show you what Pokemon Go does.
Is that rule different for Wi-Fi or just Wi-Fi and 3G?
Yeah, it's Wi-Fi, 3G, 4G. 5G when it arrives. I don't think they've changed that. All right. Let's get connected again. So when Profiler starts up, it sets various flags on the device and then pushes what we call our service, and that's what that green icon is all about. It's ready to go. So connect, it goes. All right, so since Pokemon was all the craze and I knew that I was doing this talk, I decided to check it out. Didn't have as much time to really dig into it, with it being maybe the first mass accepted AR app. I was hoping to have an opportunity to dig into something really interesting there, but have not. And the fact that you can't really use the AR functionality unless a Pokemon is near you. That kind of ruined my plans. So, but even without Pokemon around, there's still some interesting stuff going on. Let's get our frequencies back. One of the reasons why I wanted to look into Pokemon Go 2 is that I saw something in the news about people complaining about their batteries dying halfway through the day. And I was like, I bet I know why. Can anybody tell me what they're seeing?
Heartbeat.
So you'll see, we do auto scaling, so you'll see kind of jump back and forth, but I'm not doing anything in the app right now. They're telling Nintendo or whoever all about you every second. So very, very simple little thing. Obviously if I start doing things, it'll There's none near my home, by the way. I have to walk like half a mile. So, you know, when somebody complains about Pokemon Go using a lot of battery life, you know why. It's sending, it's not even sending a lot of data. What was it? 32 bytes, or 56 bytes. So 56 bytes every second it's pinging home. Those 56 bytes are costing you a little bit of battery juice every single time. You know, I haven't spent the time to do the analysis to tell you exactly how long that would last, but between the fact that it's actually rendering data or you know, doing graphics and you know, is a game. I wrote profiler. But the fact that it's a game, it's got all the touch interaction. You saw that as I was you know, touching the screen and moving things around, the temperature spiked up. Most likely that was all the processing to show me all the different Pokestops. So, does that satisfy the Pokemon Go question?
I mean, yeah, pretty much.
Kevin,
Yeah.
so if you could show us, I know this is set up, if you could show us the draw, the power draw, could we actually see the difference in terms of is it enough draw on that wireless chip to actually see that spike?
You would-
if it was batched up?
It might look small. I mean, just because it is small, right? Like it's just a tiny, tiny amount every single time that wireless chip comes up. You would probably have to zoom in a bit, but yeah, it would be there. You would see it.
And are there ways of, like, I imagine there's accumulators and whatnot to, like, be able to see that over time,
Yeah.
kind of know the difference?
Yeah. Six, 56 bytes, right? That's location data,
Yeah.
right? That's the only thing that makes sense. But do they need to every second? I don't know. I understand location is obviously critical to their game, but even if they went every 5 seconds, you know, that's a huge reduction. Yeah, and you know, I haven't looked into what about the GPS chip. My understanding, I don't know too much about that, to be honest with you. But my understanding is there has been a lot of improvements there, just because since GPS has been pretty critical, or has become, I wouldn't say critical, but more commonly used. You know, wireless, they are making advancements there too. It's not that. You know, it's not that wireless is just totally messed up. It's just that it's a very common thing that developers can do to reduce power consumption. Is just don't send data unless you really, really need to. Talk a little bit about VR AR. Because I believe Mario had. Yeah.
Yeah, actually, I was hoping you could go down GPS or something like that, but just through trial and error, I've been experimenting with GPS and how often to pull and what the battery is like, and I can attest to the fact that if you're pulling, every 20 seconds or something like that, it seems like there is a big ramp up that is trying to acquire the signal and things like that. And I found that there's kind of a sweet spot there if you have it on continuously, where it doesn't draw as much power. It's kind of converse.
Yeah, it's that ramp up that that is really the power draw. On my understanding, both of those chips.
So the same would apply for data network. So if you're to compose a packet and send it out, it's better to do that less frequent.
Yeah, do it less frequent.
Is there a kind of like a sleep state on that? If you send it maybe 5 seconds, it still has a connection. Optimize it like that. Or?
I don't know that, but definitely that's why the batching is so much more important. It's okay to send it's okay to send a meg of data, but to break that up too much, that ramp up, ramp down, ramp up, ramp down, that's what's going to kill you. So I wanted to hit a little bit on VR, AR, just because it's a hot topic. It's a hot topic in my day-to-day, making sure the developers have the tools that they need to optimize on Snapdragon for VR. We do work with all the popular game engines, Oculus, and a few others. Others that are looking into new VR products in the coming years. So, simulator sickness or simulation sickness, has anybody actually experienced that before? Yeah, it sucks.
I think you fell down.
What's that?
Going down the stairs.
You fell?
Yeah. I was thinking of going down the stairs.
Not real sickness, but queasiness.
Yeah. So in a past life, I worked in simulation, and we had simulators that wore a headset, VR, and it was for the defense industry. So I was in a mock-up Humvee, and I was the gunner, and I was enjoying myself, and they reset the system. And one of the programmers decided to modify a script, and I was just hanging out with the VR headset, just looking around, and all of a sudden it felt like my body just like jumped off and forward, and so the glasses went straight down to the ground. I had to go home. I couldn't work the rest of the day. It was the worst I've ever felt. It's a really big issue, and for me, having been around VR for so long in my past life, and seeing people physically get sick, it's something that I'm a little concerned about as the masses have access to this type of technology. You don't want to make people sick. There's legal issues there, and nobody's going to give you credit as a developer if you're making people sick. So it's something to be careful about. With mobile VR in particular, there's also the aspect of power and thermal again. I know that, or I believe that some of the major VR players have been talking about this in public, with, like the Gear VR. It gets hot on your head with a mobile device versus something like the HTC Vive. That'll get hot, but you gotta be playing for like an hour and you're sweating because you are jumping around or something. Power, same thing. I think John Carmack from Oculus said, 5 minutes is considered good right now on mobile VR, and it is. But real VR experiences, you need way more than 5 minutes. You need 15, 20, 30 minutes. So these are areas that Qualcomm is definitely looking at. We're investigating. We're making design changes, driver changes, SoC optimizations, as I call them. We're learning how to ourselves leverage heterogeneous compute across the CPU, GPU, and DSP. And then we're working with these other SDKs, the Oculus, Google Daydream, Unity, and Unreal, and others, to try to optimize their engines so that the tools that developers are using to create VR experiences are better for mobile. Sorry, was there a question? I thought somebody raised their hand. No? Okay. So a few examples about this. On the SoC optimization side, the Snapdragon 820, we're making chipset design changes that will improve the sharing across the SoC cores, so your CPU, GPU, and DSP will work better together. This is at the hardware and the driver level. Good example, the 820, the Adreno GPU. This generation from the previous generation chipset is 40% better performance and 40% less power. So offloading work to the GPU is even better for you. It's believed that you need 20 milliseconds or less to prevent simulator sickness. Right now, the Snapdragon 820 is at 18 milliseconds, and motion to photon latency. So basically, from the time you move your head to the time your eyes see the photons from the display, we've gotten that down to 18 milliseconds. We're going to continue to work on this and make it better, but Qualcomm is definitely giving serious attention to mobile VR and looking at it very seriously. I mentioned we're leveraging heterogeneous compute. The Snapdragon VR SDK is something we released. I wanted to give 2 examples of how you can use heterogeneous compute. The first one is offloading the head pose calculation to the DSP. So what that means is we're taking all the sensor data, so your accelerometer data basically, and sending that data to the DSP, and we have a very small algorithm that's running on the DSP continuously, I think at 800 megahertz. And all it's doing is giving us back what's my orientation of my head. But that's a calculation that doesn't need to be done with the CPU. We can use the DSP for that. Second thing we're using is power control APIs. Actually, from the Symphony SDK has these power control APIs where we can control the CPU core frequencies. So by default, the VR SDK tells the CPU to run at a lower level for VR calculations. And there's a specific algorithm.
Did we lose our?
I think I died.
I'll change it.
There's a specific algorithm called time warp in VR, and we basically, for that short section of code, that big on the screen, we ramp up the CPU cores to max frequency. And then once that goes done, we ramp them back down to where they should be. The reason being is that time warp calculation takes longer processing. We want the full power of the CPU. And it's what helps us get to a better frame rate, which again goes back to the simulator sickness. You need to have a good frame range, that motion photon latency, in order to prevent that simulator sickness. So, any questions on? Yeah.
So if you're offloading the head pose calculation to the DSP, does that mean you're not able to use it for like the audio processing?
No, you still can. Yeah, you still, and it is. It's used for the 3D spatial audio processing as well.
Okay.
I haven't spent a lot of time looking at the DSP with our tools, but it's really interesting because even with some of the demos that we have that do the VR or use the VR SDK and everything on this, their utilization of the DSP is still like less than 5%.
Got it.
And then the audio kicks in and you see it. Even then, I've never seen the DSP, I think, get to like 80%. It's always been maybe 50%. So there's plenty of headroom there with that chip. Any other questions?
Testing. You do the giveaways.
I know. I'm terrible about the giveaways.
Oh, you can ask questions. We can ask questions.
I know. I've been asking questions.
Okay.
Yeah. Figured I'd share this. I don't know if I'm technically allowed to, Katie. She doesn't. Oh, you don't know this story. It's okay. I'm calling him a high-profile user at Qualcomm. Likes to play Candy Crush. It's our CEO. And my boss was in a meeting with him recently doing some status reports, and he was talking about how he gets very frustrated playing Candy Crush because he experiences these frame rate drops, this judder as he calls it. And he wanted us to look at it because that's what we do. So we look at it, looks fine. Of course we can't tell the CEO, dude, the app's fine, we're not gonna bother with the developer, we gotta make an effort. But we dug into it a bit, and long story short, he's a CEO, he's getting tons of emails. He's got security stuff on his phone, he's got social stuff going on, he's got some cloud sync thing that Qualcomm has. He's a connected guy. That's what Qualcomm is. He's the CEO of Qualcomm. So what we found out is that it's actually the notifications that he's getting while he's playing Candy Crush. And I don't know if this is an Android thing. This literally happened 4 or 5 days ago. I don't know if it's an Android thing or what it is, but it's basically those background apps that are causing problems. Now, whether it's the background apps that need to be adjusted, whether it's Android that has an issue, who knows? But
It's Android.
yeah.
It's never the developer.
I like to blame Google. Anybody from Google? Maybe it's fixed in Android N or whatever, but the main reason I wanted to bring it up is that, again, even if you have a service running in the background, still be aware that you may be impacting other apps. And, unfortunately, what can we do? Really not much if somebody else is impacting our app. So it's more of an awareness thing. Android developers in general need to be aware that every single install of the app, when somebody has 300 apps on their device, and 300 apps have background services, their device is going to run like crap. Their power is going to be terrible, and so on. So the smarter we can be as developers, the better experience that we can provide collectively for the end users. But it was also the Qualcomm CEO, so I thought it was kind of funny. Because he plays Candy Crush all day. So now what? Talked for quite a bit. I want to make sure we have time for questions. I can also load some stuff up if you guys want to see more. But like I just said, it's important to consider your app's impact on the device. Even seemingly simple apps can affect battery life, can affect temperature, can affect other people's app performance. But there are these general patterns. There are things you can do as an app developer. Maybe web a little more difficult, but I'd be glad to explore that. Things like chunking the CPU processing, batching network data, trying to leverage the other SoC cores. Those are all things that you can do. All the tools I mentioned, they're at developer.qualcomm.com. They're free to download. I think you just have to create an account and agree to a license agreement, and you have full access to them. We also have forums. Me and my team are actually fairly active on those for the tools that we develop, which are most of the ones on the website. So that's it.
Giveaway.
Open to questions.
Giveaway.
Yeah.
Forums are you on?
I'm sorry?
Which forums?
At developer.qualcomm.com.
What does a minimum API for profiler? What does a minimum API?
What's the question?
What is the minimum Android API for Profiler? We just changed this because of some things. It was KitKat, I believe it's Lollipop now. Yeah.
In order to use the other processors or the other cores, is that something you just flip a switch, or is that something you actually have to put code in for?
You have to code it for.
Okay.
Now there is the Hexagon SDK if you want to program directly to the DSP.
Okay.
The GPU you can program through any of the APIs. OpenCL for compute. You can use OpenGLES 3.1 for its compute capabilities. Vulkan is going to, I believe, have compute capabilities. So you can do the GPU that way. And then the Symfony SDK, what it does is actually simplifies all that. And going into the future, it's looking at ways to allow you to write once, and it'll take care of task management across those cores. Right now, you can write for each core, and it'll still handle the task management side of it for you. So.
This is great from a developer point of view, but I was thinking, is it possible, do you have any tool that could run a profile of all the apps that are running on any specific device to identify the apps that are really causing the problems?
That are causing problems.
So that the user can uninstall and disable them.
Or do you have a naughty list?
Pokemon Go.
That's number one.
Actually, the Facebook app a year ago did something very similar. You didn't even have to be touching it. It would ping home every second. That's actually the most common, just talking general application performance, that's the most common thing I see is apps pinging home.
There is an app from Qualcomm called CPUC. It's a that one tells you also.
Yeah. So there's another.
Can I use this advice to build an app to destroy my phone? I'm serious. This is a serious question. It's not a rhetorical one. Or at least
Yes.
probability. Okay.
Yeah.
Did they actually have some virus a long time ago that actually you download it and ran it? It would somehow make the CPU run so fast that it would like blow up.
That was the Americans and the Israelis did that to the Iranian.
I'll tell you how to meld a CPU. if the system will allow you, you probably need to root and disable the scheduler. Look at the number of cores on the CPU, spawn out that many threads, and do a tight infinite loop on each. It's just a matter of time. Yeah.
What do you think of the pros and cons for Euphoria?
Vuforia?
Yeah, the one that you just sold.
Yeah, Qualcomm sold Vuforia. So, your question?
I want that like pros and cons. Like, what's your thought on that, on this SDK?
Ask me after this is over. I'm not being recorded. I can't talk about Vuforia.
Okay.
We did something. Yeah.
You were talking about video, so how does, with VR video, because there's a lot more information, a lot more processing, is that something, because I'm actually involved in a project where we're starting to look at that in mobile, so is that something I really need to worry about, or is it something that's not even really going to affect anything?
Yes.
Yeah.
Okay. Yeah, well,
I work for XVR.
that's good. Thanks.
Developer advocate. Yes.
So all these optimizations that you talked about, can you apply them in an SDK level, or it has to be at the core app level? I asked because I offer an SDK to use speaking with GPSs, and we call the GPS and location services in general a lot.
Yeah.
And so I'm wondering if I could use all these tools to optimize our SDK, or has to be
Yes, absolutely. Yeah, you could incorporate the Symfony SDK, for instance, if it was useful for you. You can use the profiler, assuming you have test apps and various things that you can use. We're actually adding the ability to instrument your own code and see it in the trace view. So you can see like your call stacks and everything correlated with all that data. So you can see how long things are taking and when it's pinging the GPS or the network or whatever. Any other questions? Well, I will be sticking around for a little bit. I got to drive to Anaheim for SIGGRAPH.
Let's ask them some questions.
Oh, okay. That's right. That's right. That's right. We got 2 drones. And a Beats headset. All right, so questions. Why does Pokemon Go use so much battery power?
It sends so much data back and forth in terms of location.
Like a drone?
Thank you.
Guys, I'm terrible about giveaways.
Ask them the name of the tool. Name the tool.
Oh, yeah. What's the name of the first tool I showed? The one that runs on the device?
Tune up.
Tune.
Tune up.
I'll give it to you. How's that?
George! George's got a drone.
For the Beats.
The other tools. What's the website? What's the developer?
If I have a machine learning app, where should I offload my GPU? There we go. Good.
That was easy.
Well, like I was saying, I'll stick around if you have any other questions or want to chat about anything else. But otherwise, thank you.
Good.